Welcome to this GCSE Science Core Chemistry revision video on rocks and building materials. In this video we're going to cover limestone and its uses, the reactions of carbonates, the limestone cycle and cement and concrete. Limestone is an example of a sedimentary rock that has not formed from the process of weathering. Limestone comes from the remains of millions of sea creatures that have died and fallen to the bottom of the sea. These creatures themselves have decayed, but their shells and skeletons have remained. Compaction of these over millions of years has turned the calcium carbonate in these bones and shells into limestone. So therefore, limestone is a rock that is largely made of the compound calcium carbonate. Calcium having the ion Ca+ and a carbonate ion having CO3-. It is formed of the remains of organisms that lived in the seas. And another key fact is that limestone is not just used for building, but it can also be processed to make a wide array of chemicals. So, the advantages and disadvantages of using limestone. The main advantages are that limestone is a valuable natural resource that can be used to make things as glass and concrete, so therefore is worth digging up. And quarrying limestone provides large opportunities for employment that can create jobs in lots of small local towns and villages. The major disadvantages of digging up limestone are that limestone quarries are visible from long distances, may permanently disfigure or damage the landscape, and quarrying is a heavy industry that creates noise, heavy traffic and other forms of pollution which damages the quality of people's life nearby. So, the major part in limestone is the fact that it's made up of carbonates. There are a wide array of different carbonates, but all of them react in a similar way. So the thermal decomposition causes calcium carbonate to break down when heated. In a minute, I will put up some equations that will go through it. So, when calcium carbonate is heated, it breaks down into calcium oxide and gives off the gas carbon dioxide. When copper carbonate is heated, it breaks down into copper oxide and carbon dioxide. So, the trick, if any question comes up asking about the thermal decomposition of a carbonate, it will always make an oxide of the metal that is in that carbonate, and carbon dioxide will always be given off. Metals high up on the reactivity series, such as sodium, calcium and magnesium, have carbonates that need a lot of energy to decompose them. Not all carbonates in group 1 or containing group 1 metals decompose at temperatures that can be reached by a Bunsen burner, as the bonds between the metal and the carbonate ion are too strong. Metals low down the reactivity series, such as copper, have carbonates that are easily decomposed. This is why copper carbonate is often used at schools to show thermal decomposition. It is easily decomposed and shows a colour change going from green copper carbonate to black copper oxide, and gives off carbon dioxide, which can be seen when passing gas through lime water. The limestone cycle summarises the reactions that happen when calcium carbonate undergoes a range of different reactions. We start off by heating calcium carbonate. As we heat calcium carbonate, carbon dioxide is given off and we form calcium oxide. To this calcium oxide we can add water that turns or reacts with the calcium oxide to form calcium hydroxide. If this calcium hydroxide is dissolved in excess water, it produces lime water, which can be used to detect carbon dioxide. And when carbon dioxide is bubbled through lime water, it turns back into calcium carbonate, which is why lime water gives a milky white colour when carbon dioxide is passed through it. We make calcium oxide by strongly heating calcium carbonate, which causes the bonds to break between the calcium and the carbonate ions. Calcium oxide is yellow when hot, but then white when cooled. When limestone is strongly heated, the calcium carbonate it contains decomposes calcium oxide, which will react with water to form calcium hydroxide. Calcium hydroxide is an alkali which can be used to neutralize acidic soil or lakes. Cement is made by heating powdered limestone with clay. Cement is an ingredient in mortar and concrete. Mortar can be used to join bricks together and is made by mixing cement with sand and water. Concrete is made by mixing cement with sand, water and an aggregate, which is crushed rock. Cement is usually made in a machine called a rotary kiln, where limestone and clay is poured in at the top and heated to high temperatures using gas burners at the end for a certain amount of time. Limestone, cement and mortar slowly react with carbon dioxide dissolved in rainwater and wear away. This damages walls made from limestone and leaves gaps between the bricks in buildings. These gaps must be filled in or pointed up. Pollution from burning fossil fuels makes rain more acidic than it should be, so therefore this causes the problem to become worse. Concrete is easily formed into different shapes, however, before it sets hard. It's strong when squashed, but weak when bent or stretched. However, concrete can be made much stronger by reinforcing it with steel. Some people think that concrete buildings are unattractive, however. So, to finalise, when thinking about your revision, make sure you turn off any distractions, make sure that you are asking questions to yourselves and not just passively reading things. It's a good idea to be making your own revision notes when going through and revising. And finally, quality revision is a lot better than quantity revision. Please follow the link below to download a summary sheet to accompany this video, and good luck with your exam.